For today's lesson, we are going to learn about the law of sines. Before we get started, let's do a really quick warm up about solving triangle ABC with the given information. First of all, the measure of angle B is 41 degrees, the measure of angle C is 90 degrees, and little c is 22. So for all of the triangles that we are going to be working with for the remainder of the next couple of lessons, our triangles will be labeled in the following way. First of all, we know that there's a 90-degree angle, so my triangle I will draw will be a right triangle. But all of the triangles in the world are not necessarily all right triangles, but in general, this is how I want you to draw your triangles. First of all, triangle ABC will have angle A, angle B, which we know is going to be 41 degrees, and angle C. Angles are always labeled with capital letters. And the side opposite will have the name of the angle that it is across from, but only lowercase. So for example, across from angle A, that side opposite of it will be called little a. The side opposite of angle B will be called little b. And the side opposite of angle C will be called little c. The labeling of this triangle is how I would like you to label all of your triangles from here on out, regardless of whatever its name is. You'll always have capital letters for the angles, and you will always have lowercase letters for the side lengths, and whatever side it's or whatever is the letter opposite, they will be the same letter, only lowercase, going all the way around the triangle. So we know that angle B is 41 degrees, the measure of angle C is 90, and little c is 22. So I would like you to please go ahead and solve this triangle, which means that we need to find all of the missing side lengths and all of the missing angle measures. Please round all side lengths to the nearest hundredth, and your angle measure is going to be to the nearest whole degree, which in this case, there's going to be no rounding. Please go ahead and solve this. When you have an answer, please restart the video and we will get started with our lesson. Okay, so whenever we're solving triangles, that means that we need to identify all of our missing side lengths and all of our missing angles. And looking at our information, I believe it would be a lot easier to find the measure of angle A first. And that's because I know that all of the angles of a triangle add up to 180 degrees. So the first thing I'm going to do is find the measure of angle A. And the measure of angle A is going to be equal to 180 minus 90 minus 41, which means that the measure of angle A is going to be equal to 49 degrees. So that is my first piece of information that I need to find. The second thing I need to find is I need to find my missing side lengths. So I always work with given information, and I know that little a is the adjacent with respect to angle B, and 22, which was given, is the hypotenuse. And I have A and H, which tells me I'm going to be working with cosine. So to find little a, I'm going to be working with the cosine. The cosine of 41 is equal to my adjacent, which is little a, divided by the hypotenuse, which is 22. I'm going to be making, I'm going to put cosine of 41 over 1 and use cross product so that I end up with A is equal to 22 times the cosine of 41. Making sure that my calculator is in degree mode, I'm going to put in 22 times the cosine of 41 into my calculator. And when I do that, I end up with 16.6. So A is equal to 16.6. You can write 60 if you want. That's perfectly fine as well. So now I have found little a. And my last thing that I need to find is I need to find little b. And with respect to 41 degrees, little b is the opposite. And we always work with given information. So since I was given hypotenuse and I want to find opposite, that's the O and the H, which tells me I'm going to be working with sine. So I'm going to write that the sine of 41 is equal to the opposite, which is little b, divided by the hypotenuse, which is 22. I'm going to put sine of 41 over 1 and use cross product so that I end up with b is equal to 22 times the sine of 41 And I'm going to put into my calculator 22 times the sine of 41. And I end up getting 14.43. Here's a little fun fact. We found that the measure of angle A is 49 degrees. And so what's really cool about triangles is that the longest side is always across from the biggest angle. The next longest side is always across or opposite of the next biggest angle. So 49 degrees was our next biggest angle, and 16.6 is the next longest side. So 22 and then 16.6. And then our smallest angle is always across from the shortest side. So 14.43 was our shortest side, and it is opposite of our smallest angle. This is something, a relationship that I want you to know and feel comfortable and familiar with, because we are going to be using that relationship as we are solving triangles that are not necessarily right triangles. So our learning targets for today are for you to be able to say, I can use the law of sines to solve any triangle, not just right triangles, but any triangle. When I am given angle, angle, side, or an angle, side, angle situation. And I can find the area of any triangle if I am given side, angle, side information. So far we've solved right triangles, but what can we do when the triangle does not have a right angle? So when we don't have a right angle, that means we don't have a right triangle. How can we solve the triangle? So when you know two angles and a side, that's where the angle side angle comes in, or the angle angle side comes in. Or if you know two sides and an angle opposite of one of those sides, that's also known as SSA, we can use the law of sines. And the law of sines says that for triangle ABC with side lengths A, B, and C, and notice how they are labeled. Little a is opposite of angle A, little b is opposite of angle B, and little c is opposite of angle C. So this is relationship of labeling is how I need you to label everything. What for any triangle ABC, the following proportion is true. Side A divided by the sine of angle A equals side B divided by the sine of angle B, which is equivalent to sine C, side C, divided by the sine of angle C. Now, I have three different fractions here, and they are all equivalent to each other and proportional. Now, please note that we only use two fractions at a time. So we only use two fractions at a time when we are setting up our proportion. So we only use two at a time. So you might see that we have like side A divided by the sine of angle A equals side B divided by the sine of angle B. Or we might have side A divided by the sine of angle A equals side C divided by the sine of angle C. Or you might see, so I'm going to put the word or right here, or you might see that you have side B divided by the sine of angle B equals side C divided by the sine of angle C. So it's just two at a time, and they are all equivalent to each other. And we can use this proportion to help us to solve any triangle. This is true for any triangle. But we typically use the law of sines if we are given angle, angle, side, angle, or side, angle, side for some situations. Side, angle, side is its own lesson. And so for today's lesson, we are just going to be focusing on angle, angle, side, and angle, side, angle. So once again, this formula is something I need you guys to please know and study. All right, example number 1 is asking you to solve a triangle for angle, angle, side, or angle, side, angle case. We're going to round all angles to the nearest whole degree, and we're going to round all sides to the nearest hundredth. So looking at letter A, it says solve triangle ABC, where angle A is 28 degrees, angle B is 102 degrees, and little a is equal to 8. So what we're going to do is we're going to draw a picture to represent this situation. So here is angle A, here is angle B, and here is angle C. And I know that angle A is 28 degrees. I know that angle B is 102 degrees. And I know that little a, which is going to be opposite of angle A, is equal to 8. So with respect to labeling, I'm going to label the side opposite of angle B, little b, and I'm going to label the side opposite of angle C, little c. And we want to solve this triangle, which means that we need to find the information that we are missing. So we are missing angle C, we are missing little b, and we are missing little c. So this is the information that we are missing. So we need to find this information. So the angle that would probably be the easiest to find first, because we know that all of the angles of a triangle add to 180. So I'm going to find the measure of angle C first. So the measure of angle C, that's going to be equal to 180 minus 102 minus 28. So I'm going to put this into my calculator. And I'm going to put 108 minus 102 minus 28. And I end up getting 50. So the measure of angle C is 50 degrees. And if you want to label it, that's perfectly fine. We found it first. Next, what we need to find is little b. So when we find little b, always use given information if possible. So what I know is I know what a and I have two of a kind is what I like to call it. I know two of a kind. And I know a side A and an angle A. So if you know two of a kind, you can use the law of sines. So I'm going to work with the fact that I have the sine, or little a divided by the sine of angle A. And I want to find little b, so I'll be setting it equivalent to little b divided by the sine of angle B. So little a is 8 divided by the sine of 28. There's your little a inside of angle A. This equals little b divided by the sine of angle B, which is 102. And now this is just a proportion, and I'm going to use cross product. So I have 8 times the sine of 102 is equal to the sine of 28 times b. I'm going to divide both sides by the sine of 28. And now I'm going to put 8 times the sine of 102 divided by the sine of 28 into my calculator, and that's going to help me to find what b is. Be careful as you put this into your calculator. So I'm going to establish my numerator is 8, so I'm going to put parentheses, 8 times the sine of 102, and I'm going to close my parenthesis. But notice I have 2 parentheses going one way. I have 1 parenthesis going the other way, so eventually I'll have a second parenthesis. So that's my numerator. And I am going to divide it by the sine of 28. So my numerator divided by my denominator, and I end up with 16.67. So 16.67 is equal to b. So that's 16.67 units. So now I need to find C. To find little c, which I know that this is 16.67, to find little c, once again, use given information. We were given A information, two of a kind, And what I need to know is I need to know what little c is. So the proportion that I'm going to set up is I'm going to work with a divided by the sine of angle A equals c divided by the sine of angle C. So little a is 8 divided by the sine of angle A, which is 28, equals little c, which is what I want to find, divided by the sine, which I found angle C to be 50 degrees. So I'm going to use cross product. So I have 8 times the sine of 50 is equal to c times the sine of 28. I'm going to divide both sides by the sine of 28. And when you do that, I'm going to put 8 times the sine of 50 divided by the sine of 28 into my calculator, and that's going to give me little c. So I have 8 times the sine of 50 divided by the sine of 28. And when I put that into my calculator, I end up with 13.05. So 13.05 units is equal to little c. Now, let's say that you made a mistake somewhere in the problem and you have, you messed up on finding the measure of angle C and you wrote that as 60 instead of 50 or some sort of error along the way. And you have no choice but to use that error to find little c. You will get dinged on finding finding the angle incorrectly. But if your work is correct in your next steps and everything that follows makes sense based on your error, I'll only ding you for your error, not on all of the other steps, because you have no choice but to use acquired information to help you find the other missing side. Since 50 degrees is our next smallest side, we end up with 13.05. So look at what we ended up getting. 8 is the smallest side across from the smallest angle. 13.05 is across from the next biggest angle. And then our largest angle is across from the biggest side. So we know that with respect to side lengths, it looks like everything makes sense. All right, let's go ahead and look at letter B. For letter B, we want to solve triangle ABC. And before we continue, I want to make sure that I establish that what we were given here from the very beginning was angle, angle, and then a side. This is angle, angle, side. That was the situation that we were given. Angle, angle, and then a side that is not between our two given angles. This time around, we want to solve triangle ABC where angle A is 51 degrees, angle B is 44 degrees, and we have C, which is 11. So I'm going to go ahead and draw this triangle. I'm going to label this A, B, and C. I have A, which is 51 degrees, B, which is 44 degrees, and little c, which is across from angle C, is 11. This is known as angle, side, angle. And unfortunately, to start this problem, I don't have two of a kind, but I can come up with two of a kind really easily. So with respect to things that we need to find, I need to find the measure of angle C. I need to find what little a equals, and I need to find what little b equals. So I'm going to label little a, and I'm going to label little b. I can find angle C very quickly. So let me go ahead and do that. So that's going to be the measure of angle C is equal to 180 minus 51 minus 44. So I'm going to put that into my calculator, 180 minus 51 minus 44. And I end up getting 85 degrees. So I'm pretty sure that that is correct because I have no choice but to use that acquired information to help me to find all the other pieces, because now I have two of a kind. And in order for us to use the law of sines, you need to know two of a kind. So I'm going to find little a first. I don't know what it is. I do know that what angle A is, and I do know 2 of a kind of my C's. So I'm going to be working with the proportion of A divided by the sine of angle A is equal to C divided by the sine of angle C. Here's a truth. You can put this fraction first if you want to. It's not going to make the problem wrong. It just means that it's going to be a different order. Not a big deal. 4 plus 5 equals 5 plus 4. Same exact idea. So A, I do not know. I do know what angle A is, and so I'm going to write the sine of 51 equals little c, which I know it's 11, divided by the sine of angle C, which is 85. So now I'm going to use cross product. So I have A times the sine of 85 is equal to 11 times the sine of 51. I'm going to divide both sides by the sine of 85. And when I do that, I end up with A is equal to, and I'm going to write 11 times the sine of 51 divided by the sine of 85, and I'm going to put this directly into my calculator. So I have 11 times the sine of 51 divided by the sine of 85. And I end up with 8.58. So 8.58 units. All right, let's go ahead and find little b. So little b is across from 44 degrees. And I'm still going to work with that 2 of a kind from the very beginning, which is 85 and 11. So 85 degrees and 11. So the proportion that I'm going to set up is I'm going to set up little c divided by sine of c is equal to little b divided by the sine of angle b. Could you flip-flop these 2 fractions? Absolutely. It doesn't make a difference. A question might be, do I have to write down this formula every time? No, you do not. But as you are learning it, it might be helpful, especially when you are visual and you have to do some matching of pieces. So little c is 11 divided by the sine of angle C, which is 85, equals little b, which we do not know, divided by the sine of angle B, which is 44. So I'm going to use cross product. So I have b times the sine of 85 is equal to 11 times the sine of 44. I'm going to divide both sides by the sine of 85. I end up with the sine of 85 canceling away. So I have b is equal to 11 times the sine of 44 divided by the sine of 85. And when I put this into my calculator, 11 times the sine of 44 divided by the sine of 85, I end up with 7.67 units. And as you're analyzing, you should notice that the smallest angle is across from the shortest side. The next smallest angle is across from the next biggest side, and the biggest angle is across from the largest side. So that is the law of sines. And once again, what you need 2 of a kind in order for you to use that. 2 of a kind means that you know a side and an angle of the same letter. And we always have an angle side or an angle side angle situation that is given to us whenever we work with the law of sines. One more concept that I want to talk to you guys about, and that is finding the angle of a triangle. If you are given side, angle, side. So this is something where if you are given side, angle, side, that means that you're given 2 sides and an included angle, you can work with the following formula. So instead of working with 1/2 base times height, sometimes you don't know what the height is. And if that's the case, there exists a couple of area formulas outside of 1/2 base times height. The first one works with sine. It says the area of any triangle is given by 1/2 the product of the lengths of 2 times the sine of their included angle. So we have the area is equal to 1/2 times side 1 times side 2 times the sine of the included angle. That's what our formula is. Area is equal to your two sides that are given to you, multiplied together and cut in half, then multiplied by the sine of the included angle. So it'll either be like 1/2 C times B times the sine of angle A. It could be 1/2 A times C times the sine of angle B. It could be A times B times the sine of angle C. So it's going to be working with all three pieces of information. So in this problem, example number 2, it says a piece of land is bordered by 3 roads as shown. Find the area of the land. So here is a side, an angle, and a side. We are given side, angle, side. And if you are given side, angle, side, we're going to be working with our area formula. So it looks like we are given little b, we know little a just going right across from those angles, and we know angle C. So the formula that we'll be working with is 1/2 a times b times the sine of angle C. It's your two sides multiplied together. So that is 1/2 times 2.3 times 1.4 times the sine of 78.1. Now, if you had 1.4 and 2.3 flip-flop, that's perfectly fine. And we're just going to put this into our calculator exactly as we see it. So I'm going to put in 0.5 for 1/2 times 2.3 times 1.4 times the sine of 78.1. And rounding this to the nearest tenths, or hundredth, or it looks like we're working with tenths here. So if we round to the nearest tenths, so that's what I'm writing right here, rounding to the nearest tenths, we would end up with 1.6 is our area. So remember, the area always has units squared. So my area is going to be about 1.6 miles squared, or squared miles. And that's our area of this triangle, area of this region. Let's go ahead and look at example 3, our last example of today's lesson. It says you are setting up a triangular flower garden in your backyard. If you lay off lengths of 15 feet and 11 feet for two sides of the garden with a 62-degree angle between these two sides, what will be the area of the garden? So let's go ahead and draw a triangle. So here's my triangular garden. It says you lay off sides of 15 feet and 11 feet with the angle between these two sides being 62 degrees. What will the area of the garden be? So once again, we are given side, angle, side. So our area is going to be equal to 1/2 times 15 times 11 times the sine of 62. So we're just going to put this directly into our calculator. So that's going to be 0.5 for 1/2 times 15 times 11 times the sine of 62. And we end up with 72.8 if we're rounding to the nearest tenths again, feet squared. So all of our units will be squared when we are dealing with area. All right, that is the end of today's lesson. If you have any questions over anything that I showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.